Okay, so let's take a look at an example. This is practice quiz 8, 1A. It says use the Laplace transform to solve the initial value problem. So we're given here y prime minus y equal to 2 cosine of 5t with y of 0 equals 0. Okay, so we're going to show how we can use the Laplace transform to solve differential equations. Let's first take the Laplace transform on both sides. So doing that, we get then okay, so I took the Laplace transform on both sides. Now the Laplace transform is linear, which means it will distribute in here. So doing that, we get then okay, so we get this. Now if you look at Theorem 17, when n is 1, it reduces to this, the Laplace of y prime equals s Laplace of y minus y0. I'm going to apply that right here. And then we've proven that the Laplace of cosine of kt is s over s squared plus k squared. This was some theorem, I forget which one. We've proven all these properties. But we're going to be using the cosine guy here. Looks like the k is going to be 5 and theorem 17 here. So doing that, we get then okay, so again, the Laplace of y prime using theorem 17 when n is 1 is equal to s Laplace of y minus y0. So I replace Laplace of y prime with s Laplace of y minus y0, y of 0, and still have Laplace of y here. Then the Laplace of cosine of 5t, the k would be 5, so here it'll be s over s squared plus 5 squared. So using this guy here. And now y of 0 is 0. That's what we're given here in this question. So we can replace this with 0 now. So doing that, we get okay, so replacing this with 0. Then both these have Laplace of y. So I've factored out the Laplace of y on the right. So factoring out this one, there'll be an s left in that. And there's like a 1 in front there. So factoring out this one, it'll be s minus 1 Laplace of y equals 2s over s squared plus 25. Let's now solve for Laplace of y by dividing both sides by s minus 1. So doing that, we get then okay, so we have the Laplace of y then equals 2s over s squared plus 25 times s minus 1 down here. Okay, so we're going to have to now, well, you can see now my objective is to solve for y. So if I take Laplace inverse on both sides, I could solve for y. But I'm going to have to find the, before doing that, I'm going to find the partial fraction decomposition for this. So I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have our Laplace of y equals 2s over s squared plus 25s minus 1. So we want to solve for y. I'm going to take Laplace inverse on both sides. So here and here. And Laplace inverse of Laplace of y will just be y here. So this is just y. So our y equals Laplace inverse of this guy here. And to figure this out, we're going to have to find the partial fraction decomposition. So let's do that next. So let's find the partial fraction decomposition. So we have this guy here. I'm going to call the denominator d. So since you have an s squared plus 25, and that's, if you factored it, it would have imaginary numbers. So therefore, you can write it. You'd have to write it as as plus b over s squared plus 25, because again, this does not factor unless you use complex numbers. And then this is it'll be c over s minus 1. So this is how the partial fraction will look. Let's multiply both sides by d. So doing that, we get So multiplying by d on both sides here, these will cancel here, it'll be just 2s on the side. D times this, the s squared plus 25 will cancel, it'll be an s minus 1 left here. And d times this, s minus 1 will cancel, it'll be s squared plus 25 left here. Okay, our job then is to find a, b, and c. So we got 3 unknowns. We could multiply out and equate coefficients, but I'm going to do it a different way here. I'm going to choose s to be different values. So for example, to find c, I could choose s to be 1 here. That would disappear. I could find c that way. Let me write that here. Okay, so to find c, we're going to let s minus 1 equal 0. So that means s is 1. So put 1 in place of s everywhere. We have 2 times 1, a times 1 plus b, 1 minus 1 plus c times 1 squared plus 25. This is 0 right here. Just going to make that whole part 0. It'll be 26c equals 2. Okay, so yeah, 26c equals 2. Solving c then will be 1 over 13. Okay, so I know that the c is 1 over 13 here. Now I need to find the a and b still here. Next, I'm going to show you if I chose the s squared plus 25 to be 0, then I'd be able to find the. I'll show you that I'll be able to find both the a and b at the same time if I do that. So let's note that here. Okay, so I claim to find both a and b at the same time. I'm going to set the s squared plus 25 equal to 0. So that means that s squared would be negative 25. Then taking square root on both sides, it means that s is plus or minus square root of negative 25. Well, the square root of a negative number is going to involve an I. So square root of 25 is 5, and square root of minus 1's I, so it's going to be 5i. So let's choose s to be 5i. So let's put 5i in place of s up here. So doing that, we get then. So putting 5i in place of s here, 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 and here. Well, putting it over here by design will make it 0. So it'll be c times 0. That'll be 5i minus 1. That'll be a times 5i plus b, 2 times 5i. Okay, I'm going to write this as negative 1 plus 5i here. And I'm going to write this as 5ai here. So doing that, we get. So we get this. Now I want to solve for the 5ai plus b. So I'm going to divide both sides by this. So doing that, we get then. Now then, 5ai plus b equals 10i over negative 1 plus 5i. Okay, I want to get rid of this fraction here. So to get rid of this fraction, you have to multiply top and bottom by the conjugate of this one. And the conjugate would pretty much take away the plus and put a minus there. So let's multiply top and bottom by conjugate. So doing that, we get. Okay, so multiply top and bottom by the conjugate. So now it is going to distribute this guy, this with that, here, 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 here. So doing that multiplication, we get then. Okay, so multiplying it out, you have 10i times minus 1, so it'll be negative 10i. 10i times negative 5i, be negative 50i squared. Then here's the difference of squares. It's going to be negative 1 squared minus 5 squared I squared. And recall that I squared is minus 1. So replacing the I squared at minus 1 here and here, we get then. So replacing the I squares at minus 1, we have negative 10i, then it'll become negative 1 times this will be 50, and that'll be 1 plus 25, so it'll be 26 here. Okay, so I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have 5 ai plus b equals negative 10i plus 50 over 26. We can break this up as negative 10 over 26i plus 50 over 26. Now for these two sides to equal, the 5a must correspond to the negative 10 over 26 because they both have an I in them, and the b must correspond to the 50 over 26. So let me note that here. We'll have 5a equals negative 10 over 26 and b equals 50 over 26. Divide, or think of multiplying both sides by 1/5 here, and we can simplify this a bit, reduce it. So we should get then the following. So let you check when you solve these things and reduce them. You get then a is negative 1 over 13, b is 25 over 13. So let's rewrite this guy now, making these substitutions. So doing that, we have then okay, so replacing the a, b, and c up here. Notice the c, the a, and the b all of 13. So I pull that in front here. So it's going to be then a, so what's left of a is negative 1, so it'll be negative s plus b, so it'll be 25, because the 13's out over here, plus 1 over s minus 1. Okay, now we're going to replace this up here with the partial fraction decomposition. So let me erase a few things and we'll keep going. Okay, so I'll have our y then is Laplace inverse of this guy, and is the partial fraction decomposition we just found here. Now Laplace inverse is a linear also, so we can pull the 1 over 13 out and distribute this guy in there. So doing that, we get then okay, so pull the 1 over 13 out in front, and distribute the Laplace inverse to this guy and to this one. And I'm going to break this up into two pieces and distribute the Laplace inverse inside there also. So doing that, we get okay. So I broke this up as I pull the minus sign outside this one too. So it'll be Laplace inverse of s over s squared plus 25, or minus Laplace inverse, and then plus 25, Laplace inverse of 25 over s squared plus 25, plus Laplace inverse of 1 over s minus 1. And recall these things that we've proven in previous theorems. So the Laplace inverse of 1 over s minus a is e to the at. Laplace inverse of k over s squared plus k squared is sine kt. And Laplace inverse of s over s squared plus k squared is cosine kt. So it looks like these guys up here. In particular, here it looks like the a is 1. And over here, this one looks like the sine one, but we need an s squared, k squared. It looks like our k squared would be is 25, so the k would be 5 here, and same over here. Let's note that. Okay, so my a would be 1 here. So this first guy is going to be e to the t. And here the k squared would be 25, so the k would be 5. But we just need a k on top. We actually have a k squared on top. So I can pull a 5 out and leave a 5 there. So let me do that here. Okay, so I pulled a 5 out, left 1 5 here, so it looks like this guy. And this one seems like it's already set up. The k would be 5 here also. Okay, so applying these then, we get the following. Okay, so Laplace inverse of this guy. The s on top is the cosine one, so it'll be negative cosine 5t for this one. And this guy has the k on top, so it looks like it's a sine one, so it'll be 5 sine of 5t. It's just, this guy is just e to the t. Okay, so this should be our y here. So let's just summarize here. So summarizing, our y then will be, let's multiply this 1 over 13 in, so it'll be negative 1 over 13 cosine of 5t plus 5 over 13 sine 5t plus 1 over 13 e to the t. So this should be the solution of the differential equation we're trying to solve, the initial value problem. Okay, I'll let you, if you want, you can check to make sure it is, but it is, I checked it, but I'm not going to check it here. So we're done, so let's leave it there in the video.